Okay, so we are going to do a quick review of dilations, and we're going to start our review of dilations by looking at scaled copies. Scaled copies are when a figure enlarges or reduces. Sometimes it'll get smaller. Okay, so let's look at these pictures right here. They are scaled copies. The big one is or the second one, B, is a scaled copy of the first one, A, and we want to find side lengths and the scale factor. Okay, so these are like dilations. We've talked about dilations. We just want to look at them again before we do our next topic. So let's look at the original side length. So here's our original figure, and you're going to take one of the sides. Does not matter. You could take the short side, the long side, whatever's easiest for you. You're going to find the original side length. So I'm going to look here, and this has a side length of 1, 2, right? That's 2 spaces. So my original side length is 2, and I'm going to do the corresponding side length in figure B. So I need to do the one that matches up with it. So it has length 1, 2, 3, 4. So that's 4 spaces. It has a length of 4. So the scale factor, what do I multiply 2 by to get 4? Well, 2 times 2 is 4, so my scale factor is 2. I doubled that. All right. So now I have 2 triangles, and triangle B is a scaled copy of triangle A. So I'm going to look, and I have this little short one right here. This would be easy to count, right? So it has a side length of 1. All right, so I'm going to do the corresponding side in triangle B. It has side length 1, 2, 3. So the new side length is 3. So my scale factor, 1 times what is 3? 1 times 3 is 3, right? So my scale factor is 3. Um, so whatever you multiply by, that's the scale factor, okay? So let's look at this figure here. I want to look at, okay, this one got smaller, right? So my original side length is right here, and I've got length 1, 2, 3, 4, 5, 6, 7, 8 spaces. So my original length is 8. And my new side length, it got smaller, is 1, 2, 3, 4. That's 4. So what happened? How do I get from 8 to 4? Well, 4 is half of 8, right? So my scale factor is a half. So if it gets smaller, it's a fraction. If it gets bigger, it is a whole number. So let's review what we know about a dilation. A dilation is a transformation that, hold on a second, I messed up. I forgot to change my pen. Sorry about that. A dilation is a transformation that enlarges or shrinks, reduces a figure using a scale factor. If the scale factor is greater than 1, like we saw just a minute ago, this figure becomes bigger. And if the scale factor is less than 1, the figure becomes smaller. Okay, so let's look at examples that have been dilated, and let's see if we can figure out the scale factor. So my original scale, or my original side, is 3. My new side is 9. What did I multiply 3 by to get 9? It's 3 times 3, right? So my scale factor is 3. Okay, my original side is 6. My new side is 3. What do I multiply 6 by to get 3? Well, 3 is half of 6, right? So 6 times a half is 3. So my scale factor is a half. Notice it's a fraction. It got smaller. Okay, my new side is 6. My original side is 6. My new side is 30. What happened? What do I multiply 6 by to get 30? I multiply 6 by 5. So my scale factor is 5. Okay, so let's review how to do a dilation. This says triangle XYZ has vertices X at 3, 2, Y at 4, -2, and Z at -1, -5. Find the new vertices after a dilation with a scale factor of 4. So what's going to happen? Everything's going to get 4 times as big, right? So to find x prime, I'm going to take x, which is 3, 2, and I'm going to multiply the 3 by 4, and I'm going to multiply the 2 by 4. So you're going to multiply both of those by 4. So 3 times 4 is 12, and 2 times 4 is 8. Okay, so that's how you would find x prime. Y has coordinates 4, negative 2. I'm going to multiply both of those by 4. 4 times 4 and negative 2 times 4. So 4 times 4 is 16. Negative 2 times 4 is negative 8. Whatever the scale factor is, that's what you multiply by. All right, z has coordinates negative 1, negative 5. So to find z prime, I'm going to do negative 1 times, guess what? 4, because that's my scale factor. And I'm going to do negative 5 times 4. So negative 1 times 4 is negative 4, and you can use your calculator to help you if you need to. And negative 5 times 4 is negative 20. So whatever the scale factor is, that's what you multiply each of the coordinates by. Okay, so this last example, triangle ABC has vertices A at negative 8, 8, there's A. B is at negative 4, negative 4, there it is. And C is at 8, 0. And we want the vertices after a dilation with a scale factor of 1/4. So is this going to get bigger or smaller? Okay, so this is going to get smaller, right? Because we have a scale factor that is less than 1. So what you're going to do, if my scale factor is 1/4, that's going to be the same thing as dividing by 4. When it got bigger, we multiplied, right? And when it gets smaller, we're going to divide by 4. So you can do this in your calculator if you want to. I have negative 8, 8. That's A, right? So I'm going to do negative 8 divided by 4 and positive 8 divided by 4. So negative 8 divided by 4, use your calculator. That's 2. 8 divided by 4 is positive 2. All right? Look at B, negative 4, negative 4. So I'm going to do negative 4 divided by 4 and negative 4 divided by 4. So B prime is going to be, you can do that in your calculator if you need to, negative 1, negative 1. And C is 8, 0. So I'm going to do 8 divided by 4 and 0 divided by 4. Well, 8 divided by 4 is 2, and 0 divided by 4, 0 divided by anything, is 0. So let's just graph this one just to see. So I have negative 2, 2, that's A prime. Negative 1, negative 1, that's B prime. And C prime is at 2, 0. So there's C prime. Let's see if I can connect these at all and it look like a triangle. So look at that. That's a fourth as big, right? That's a smaller triangle, and it's a fourth the size of the original, of the pre-image. Okay, so that's how you take care of dilations. It's all about multiplying or dividing to get bigger or smaller. So now you're ready to go do your practice Google form.